The power factor of a parallel resistor inductor capacitor circuit can be determined using different methods, and each method yields a different formula. The resulting power factor values may appear to be different, but they are all correct within their respective contexts. Method 1 involves power factor as resistor divided by impedance. The formula is power factor equals resistance divided by impedance. Impedance is the impedance of the circuit, which is a complex number with both magnitude and phase. This method is valid if the circuit is purely resistive or inductive. Method 2 is power factor as cosine of phase angle. The formula is power factor equals cosine of theta. Theta is the phase angle between the voltage and current in the circuit. This method is valid for any type of resistor inductor capacitor circuit, including parallel circuits. Method 3 involves power factor using current ratio. The formula is power factor equals inductive current divided by resistive current. Inductive current is the current through the inductive branch of the circuit. Resistive current is the current through the resistive branch of the circuit. This method is valid for parallel resistor inductor capacitor circuits. Regarding the efficiency calculations, the true power in a parallel resistor inductor capacitor circuit is only the power dissipated by the resistor. This is correct. In such a circuit, the power dissipated by the inductor and capacitor is reactive power and does not contribute to the useful work being done by the circuit. However, the efficiency of a parallel resistor inductor capacitor circuit is not always 50%. It depends on the values of the components and the frequency of the applied voltage. The efficiency can be calculated as efficiency equals true power divided by apparent power. True power equals power dissipated by the resistor. Apparent power equals voltage times current. The constant 50% efficiency is likely due to using a circuit with specific component values and frequency that happen to produce an efficiency of 50%. In summary, the apparent contradictions in the methods for calculating power factor and efficiency in parallel resistor inductor capacitor circuits arise from using different formulas that are valid under different conditions. Each method yields a correct result within its own context. The efficiency of a parallel resistor inductor capacitor circuit can vary depending on the component values and frequency, and it is not necessarily constant at 50%.